So my name is Sarah Mitchell. I work in London on the Solutions Architecture team in our London office. I focus entirely on financial services customers in London. So processing video isn't something I do an awful lot with. So I have taken on this challenge to do this talk. So we're going to talk about how various ways of building video-enabled applications and ways for integrating that with AWS recognition service so that you can kind of reason and do some work with those videos. Now, this is a funny slide to start with. This is a data architecture slide, so data architecture for AWS. And the reason I've put this slide in is that video is now becoming a really viable source of data for a lot of organizations. And it's something that's been very, very hard to process up until now. Really hard to derive meaning from video images in general. And with the advent of AI services such as recognition, then that becomes far more accessible. You don't need to have deep skills in machine learning to build out those video processing models in order to interact with this data. And so all sorts of use cases become possible. So Amazon Recognition, I like playing Scrabble, and it really grates to me that we spell it with a K, but so that's just my own personal issue. There are a rich set of metadata that recognition gives you the ability to query from images, and it's all available over the API that you're kind of used to with AWS. So we can pick out objects and scenes within images, whether that's a person on a bicycle, a street, a dog, a ship, a cup, and there's thousands and thousands of objects and labels around those objects that you can extract. Facial analysis is the one that's the sort of default that you expect to be able to do. Pick out features from a face, understand whether that person is happy or sad, wearing glasses, they've got a beard, all sorts of things. But then from that, how do you compare that face with other faces in another picture? Can you find a match for a face, and how similar are those two images? So how confident are you that those two faces may be taken different times, different light, different scenarios, all within a crowd? How can you match those faces? We also have celebrity recognition within the product, and I'll show you a use case for that. It always feels like a bit of a toy, but we've got a customer called CSPAN who've used it really to their advantage. And finally, image moderation. So how can you detect unsuitable content within an image and have that highlighted as you process it? So that's also really important for certain use cases, as you can imagine. So if we look at celebrity recognition, so this is the man that pays my wages, ultimately. And he is classed as a celebrity within recognition. And so a customer called CSPAN, who are an American TV company, essentially. They're sort of public affairs network on the American TV network. So they were spending an awful lot of time tagging TV images for who was in those certain images, who was in those particular feeds of TV streams, news items, and you can imagine just the constant stream of content that they had. So they used recognition, and they actually built the service within 3 weeks. It was a really quick turnaround for them to index all of the content that they had coming in on their video streams and identify who was in each stream, which politician, which celebrity, all the different people, and they could then index all of that content, and then that content's queryable. So if they want to find videos with Britney Spears, they can search for that. If they want to find videos of Barack Obama, they can search for that. If they want to do videos with both of those people in the same shot, they can also do that. They reckon it saved them 9,000 hours a year just in curating and tagging video content for their service. So a really vast saving in time. But also quite a simple architecture ultimately. Stuff on the right-hand side is their streaming in encoding. So that's the stuff that's dealing with that raw video content. But once that then gets passed as images into an S3 bucket on AWS, it then triggers into an application that basically just passes those images into recognition and returns the metadata out of recognition and then stores that metadata in another S3 bucket. So quite a simple flow in order to achieve quite a valuable output. So we're going to go and I've got a few demos in this pitch, which is always adds to the excitement of doing a presentation to a lot of people. But let's see how we go. Now, this demo is a website that we've built, and it happily, I'm going to put my glasses on as well, because otherwise I can't see what I'm doing. So what it does is it's a simple HTML website that's sitting on S3. It's got a CloudFront front end. And it is streaming the content of my face and analyzing how lovely I look today. In the server end, there's a collection running, and we're going to have a little look at how you build that in a minute. But there's a collection, and there's a picture of a colleague called Paul Armstrong, who actually built this. So he is classed as the only Amazonian, the only person who works for Amazonia in this collection. So this service is saying, okay, I've got a face of a person, I know it's a person, and I'm confident, and we've listed some of those tags. But it's also then comparing my face with Paul's face that's sitting in this collection and saying, actually, this isn't someone that I know. So this is actually quite a simple piece of code. So we can just have a quick look at that before we move on. So all that we've got sitting on S3 is this HTML file, index.html file. So a few key pieces, really, that are useful to see. There's a couple of JavaScript libraries that we've used to build this. One is webcam. So that's providing all the interaction with the webcam sitting on my laptop here. And the other one is Chatty Cafe. Now, Chatty Cafe is a really nice way to wrap functions that talk to Polly. So AWS has a service called Polly that does text-to-speech, and Polly enables you to pass in a written piece of text, and she will speak it back to you. But she will also, I give her a she, she'll also add, she's an artificially intelligent service, so she doesn't just repeat it back to you, but she adds the normal kind of intonation that you would expect from language. So it's a synthesized voice, but it actually has a cadence to it that you would expect. And this you can get Chatty Cafe on Git. There's a link that you can just search for. So what do I do? So I set up some credentials to talk to Chatty Cafe, so I need to give her permissions to talk to Polly. But ultimately, the key bit of code here is really just going to recognition and comparing faces. So this is just a simple call into the recognition service on that HTML page that then reports back what it's seeing. So let's go back to some slides. So this is the architecture, just to kind of close out on that demo. So this is the architecture that basically is supporting that piece of code. And it's in some HTML that's sitting in S3, and it runs and interacts with recognition. And recognition has an image collection that it's stored. So let's just move to have a look at that. Now, when you create a collection in Rekognition, you pass in each individual image that you want to have in that collection. And it scans those images, so you use a index faces tag, and it scans those images and extracts all the metadata out of each image that is important. So it's not actually storing the individual faces within the image, it's storing the metadata about that image, and that's how it's enabled to compare one face to another with varying degrees of confidence. What's also nice is that because it's running on AWS, you can hook all of this into the normal CloudWatch metrics, so you can get all that data back out on the service, you can see what's being invoked, who's invoking what, and how that service is running. So you can really build out a properly operational service. So this is another part, so we did just look at this code. So this is the other part of the API that we've built into that function. So we're searching faces via that data. We're using a series of code commands in the application. So not only are we trying to search for a match, but we're also trying to determine the similarity. So we're trying to say how confident are we that individual face matches the face on the second image. And we can extract all of that data just using the API, so that all of it is available as part of that API, and it's really quite simple just to build out a flow. But then once you've got that flow, you can also then use other parts of the platform to create more complicated applications. So there may be something that you want to pass to another machine learning model. You may want to integrate this service with other parts of your application, store data in databases, pass it on through Lambda to other parts of the service. So because there is this sort of API-driven metric of interacting with it, then you're able to just create those complex workflows through the service. So this bit of code here just shows you what you would need to do in order to create a collection. So it's a fairly lightweight API here. So we start with the CLI. So the images show the two different parts, really, of the API. On the left-hand side, you've got the sort of administration side, how you build up your record, how you index the faces that are sitting in that collection, and have that operationally able to query and see what you've got. On the right-hand side, then you need to be able to do those real-time queries. So who is this person? Does it match the person I want? Is this a celebrity? Get that celebrity information out. So when we create the collection, we give it a name, and then that exists as an entity within Rekognition, and then we pass in each of the individual faces that we want to add to that collection. And the example here, the faces are all being stored in an S3 bucket, so you've got a sort of centralized place. Now what you could do is programmatically generate your collection and add faces to your collection as you go. So if you were wanting to build an application that wants to know if someone had been to the office before or something like that, you could tag a face. Does it exist? No, and then add it in dynamically to the collection, and then that's available for the next query. Okay, so that first example then was looking at taking streaming video data, but then taking stills of that data at regular intervals and running that into the service. But what if you want to then process live video? And there are a whole load of other use cases that then become interesting if you've got moving content that you want to process. And so charging into the rescue here is Amazon Rekognition Video, and that will enable you to process both stored video, so you may have captured video that you've stored away in S3 or some other location, as well as live video streams that are coming in on Kinesis video streams. So different use cases for both. What's nice about recognition video is that it enables you not only to do what I call ordinary recognition does, but it also enables you to track images through a video. So it will tag an image, and it will continue to track that image across the whole video. It labels those, and that enables you then to have timestamps on those individuals so that you can then search through a video for instances of a person at a particular timestamp, and it can scroll back and forth through that piece of content back to where that image resided. So if we just look at an example here that's been built. So this is just a camera on a street, but you'll see how the application picks up 4 individual people and tracks them across the screen, as well as the lady walking up on the side with the dog, and the vehicles as they've passed through. Now, the front-end application, someone's built the graphical interface that's showing the coloured dots and everything else, but it's recognition that's managing, identifying those unique people and keeping track on where they go. So what does this make possible? There are all sorts of different use cases that you can then enable with this kind of technology. Lots of sort of CCTV type applications where you want to just have a security effect on a train platform, for example, or perhaps preventing people from trespassing on railway tracks. You maybe want to put in place some kind of CCTV. You might want to put some camera on your front door so that you know when you're sitting watching TV, you know if it's someone trying to sell you something or whether it's your best mate knocking on the door. Or things around personalization for customers, and whether you can know when a particular customer has come into your branch or your shop, and make sure that you're ready with the right information for them when they come and sit down at your desk. So there's all sorts of different use cases that you could build out. I'm sure you've got more than my head can think of. So what does this architecture look like? It's a little bit more complex. So we start with our camera, and we're not particularly fussy on the camera. There is an application that needs to sit in the middle that then provides the mapping between the camera technology and managing putting that content onto a Kinesis video stream running on AWS. And that's just a set of SDKs that you just need to build an application out of, and there's a number of samples for different languages that you can download and build out. Once that data is then put onto Kinesis video streams, Kinesis video streams then interacts and integrates really tightly with recognition video. And so that stream data then gets passed to a stream processor within Amazon Recognition. And it's that stream processor that does the interaction with recognition to say, this is this unique individual, this is a face, this matches against a face I have ready, and it extracts all of the data out of that stream that's come to it via Kinesis video streams. So then you need to do something with the data that's come out of the stream processor, and you pass that resultant data back onto a Kinesis data stream at that point. And then that data is then available. So what we've done here is we've built a Lambda that just processes data as it lands onto that data stream, reasons about that data, and does a very similar thing. It says, okay, does this face sit in the collection that I already have? And if it does, then I'll send a notification out to an email address. And if it doesn't, then I'm off. I'm not caring about this image. So this is just a little bit of a recap here on that. So at the top, we've created that Kinesis video stream, and it's a fairly lightweight command to create that stream. What you get back is a resource identifier, an ARN for that video stream. You then create your stream processor. That's the part of recognition that's going to process that stream data. Your data arrives from the camera, arrives on the video stream. The stream processor will then pass the data it retrieves back from recognition, put that back onto Kinesis, and then the Lambda fires to advise you of the results. We're going to have a little look at it in a moment. Just a couple of points about those producer and consumer applications. So the producer application, as I said, we don't care too much about the content, where it's coming from. It can be any streaming device. It might be buffered for some period of time on the device, or some kind of after the fact, so some pre-recorded video. The producer libraries are supported on Java, Android, and C++, so there's a bit of limitation there. And then the consumer application, we've written this in Python, so it's just a Lambda function that's interacting with the data that's come from recognition. So that's relatively straightforward. So I'm going to go back now to the other part of my demo. Where we're all very, very reliant on the network. So I've got a few things going on here. I've got an application, so I need to kick off the application. Can we have access to all of my laptop rather than just the... just the PowerPoint? Do you want me to stop the PowerPoint? There we go. That's okay. Right, back to where we were. So this is my inbound processor. So what this is going to do is it's sitting and processing content from my webcam. It's just going to sit there chugging away, and we'll just ignore that for now once that's running. So what I'm going to do now is go back to where my Lambda lives, and we'll just watch as that starts to ingest this data. So if we just take a quick look, we'll take a quick look at this. So this is my inbound Kinesis data stream that's acting as the trigger for this Lambda function. It really is just a data stream that's funneling data out of that application that I've just started. My Lambda function itself will process an application that I've written that I've imported as a deployment package in Lambda. And we'll look at that in a second. And then at the output of that, it's generating logs, but what it's also doing is it's taking the contents of the video, so when it finds matches, it stores each and every instance of that metadata in a database, but it also pumps that data out onto the data stream for that to then be funneled back across SNS. So I end up with a lot of email as a result of this demo. So let's take a little look and see what's going on behind the scenes. So in the logs, what we'll be able to see is the messages as they pass through the system. I'm just going to limit this down a little bit. It jogs away. It's still on UK time. It reminds me that it's actually only lunchtime at home. So, if we look here, what we can see now is that's the data as it comes back out of recognition. So it's giving me this a face search response. It tells me it's detected a face. It runs through some of the parameters of the face it's detected. So these are the labels that recognition is adding to that image. It's then passing that image into the collection of faces that I have stored in recognition. Now, in this particular collection, it's actually got a picture of me rather than a picture of my colleague, Paul. So it's matching my image with a confidence level of 99.9, so it's pretty certain it's me. And then it just goes through some of the labels that it's pulled out of my face on that image. What it's then done is it's sent a message taking the results of that data and emailed me the output. Now, I did actually kill off my email so that we didn't end up with all of my email being broadcast to the rest of you. But let's just see if we can do this. So, let me just see what's happening on here. This is where it all goes strange. I might just take that out of there. I'm very reliant on the network sending me an email. It's maybe not going to send it. Here we go. Outlook having a slow day. No, I can't get onto my emails. You're going to have to trust me that it was sending me a notification. I'm afraid that hasn't worked this morning. Okay. The joys of a live demo. So let's go back to the slides. So we've done a few things there. I wanted to just, I know it's just taking its time. There we go. Yeah, it's coming. Hey, okay. So we've looked at two different ways of processing that video. Now, they sort of start sort of increasing in complexity, but there will be some scenarios where the recognition model isn't sophisticated enough for the use case that you've got. And whilst it's pretty broad and it covers all sorts of scenarios, there are other instances where that doesn't quite work out. The other angle is also you might want to be doing some processing closer to the data itself. And I know Julian mentioned Deep Lens earlier. What Deep Lens enables is that processing of that data, that video data at the edge. So you can do some analysis on that data and either have an immediate response in that locality or limit the data that you're then streaming to the back end, back up to the cloud. So if you're trying to process large quantities of data, then that might actually be a more effective way of doing it. So we built a little demo around Deep Lens at the office that kind of demonstrates that. And what that was doing was just trying to provide a leaderboard around how many cups of coffee people in the office were consuming. So it had a model sitting on the Deep Lens that was able to recognize a face and a cup of coffee. So it required both both things to be in the image in order to then say, okay, this is a valid use case. I'm going to pass this image back up to the service running on the cloud, and then I'm going to use recognition to say, is this person already competing in the coffee drinking competition? If they were already there, it would just increment their count. And if they didn't have a record already, then it would add them to the collection and they'd start as a new user. So the code on the device was doing the initial inference with the custom machine learning model sitting on the device that we'd built using SageMaker. It would do that model inference locally, and then it would do a publish up to an S3 bucket sitting on the cloud for the positive results. And then we built this leaderboard of people around the office and various coffee drinking activities. And it would tag just each and every interaction with the service as it went. So I've done a fairly whistle-stop tour through a number of different scenarios that you might want to deploy to use video processing in your applications. I hope it hasn't been too fast, too lightweight. It's sort of trying to cover all sorts of use cases and some of the pros and cons with each different one. I'm going to say thank you to all the people who helped me with their demos. These are all my colleagues back in London who were really, really helpful. I've got one, I'm going to risk it with this and see if the network works. One last video. This is video application that's built on top of recognition. And what this does when it finally comes back to life is see if the network works. It may not run across this network. What this video does is, as it's scanning the video, they've used the tagging mechanism. So where we say we're going to tag things and timestamp them. So it then tags each and every individual instance of things that it's found, and then enables you to scan. Oh, here we go. Scan back through the video to see those images. So if I click on here, as you see, if I've clicked on bottle, if I go here, it's got 2 instances of a bottle in that video. So I can do that with all sorts of things. For person, it goes right back to the beginning and says, here's the first person, and scans through the video all the way through. So that really sort of shows to you the kind of complexity of application that you can build, and that is just interacting with recognition with some good front-end developer skills, which I don't have. But just wanted to show you that as just a different way of building out a solution with this product. I hope that was helpful. I'm happy to take some questions. I'm not sure when the next session is running, sort of how quickly afterwards. We've probably got about 5 minutes. Thank you for listening.